In a previous video, I spoke about the difference between storage and memory in the context of where our contract stores data. Now we're going to look at storage and memory as to how Solidity references values. So I'm kind of referring to this diagram here. So figuring out what storage and memory are with relation to Solidity and how it references values is difficult. So I have an example contract that's easier to understand, and it's going to illustrate the differences between memory and storage. So let me head over to that, and that's right here. All right, so this numbers contract has a single variable, an array of integers called numbers. Inside the numbers function, we take the array and we push the numbers 20 and 32. So if I were to now print out everything inside of numbers, I would expect to see something like 20 and 32. So I've added another line of code inside this function where I declare a new variable and I assign it a value. And I declared a new array of integers called myArray, and I assigned it the value of numbers. Now, when I do that, I still have this warning over here. So if I go here, see variable is declared as a storage pointer, unused local variable. So the first one is really related to the same error that I have in my original contract. So to make this warning go away, I'm gonna implement the fix to make the warning go away, and then I'll talk about what that keyword is doing for me. So because it's a keyword, it's like that. Okay. Now that warning should go away, but it says unused local. Okay, it's talking about unused variable. All right, that's fine. Okay, so now I only have one warning which says unused local variable. That warning means that I declared a variable but never used it, and that's fine. The storage keyword resolved the warning message. So what's going on with the storage keyword? What is the purpose of this storage keyword? So any contract level variable is always stored inside the storage area of the contract. Let me pull up a diagram. And what I've done here, I've kind of broken down the code that I'm using here. This one here. Share this with you guys. All right, so at the right-hand side of my equal sign, I have the numbers variable. And as we well know, it refers to an array of integers that is stored inside of the storage area of my contract. So here's the interesting part. When I use the storage keyword, it changes the way in which the new variable called myArray works. So the storage keyword changes how a variable works. The keyword storage makes the variable point directly at the exact same location as the numbers variable is pointing at. The myArray variable will be pointing to the exact same array. I'm going to show you proof of that in this case. So I'm going to reference my array. I'm going to access the first element and then set the value to be 1 like so. So right here, I'm going to do my array, and I'm going to access the first. All right. Okay, so when I deploy this contract here in Remix, I'm going to retrieve the first element inside the numbers array. So I'm going to go ahead and hit the deploy. So I'm going to go over to the Run tab, hit deploy. So it looks like some kind of error happened here. It did not deploy. Okay. Well, that's not, oh. I believe I need to, there we go. Now let me try it. There we go. So guys, if you're doing this at home, make sure that your environment is JavaScript VM. Sorry about that. All right. So so what I did here was, see, I already have it here. Well, no, now that makes me look like a liar. Okay. So usually I have it here. And what's wrong with my compiler? No, that should be good. Problem here is because I still have that error. All right, yeah, so anyway, make sure your environment is JavaScript VN. I didn't ensure that, so that's why I didn't work the first time. All right, so I deployed the contract by hitting the deploy button. So now if I access the first value, and the way you would access the first value is you type in a 0, hit enter, and there's your first value. Okay, and so I get back a 1. So if I access the second value, which is 1, so I type in a 1, click the button, I get back 32. And if I try to access the third value, and the third value is an index of 2, okay, I get nothing back because there are only 2 elements inside of numbers. So now this numbers array looks like 1 and 32. So in other words, this array looks like this, 1 and 32, right? Whereas before it was 20 and 32. So as soon as I use the storage keyword, it changed how the variable behaves. It makes it look at the exact same location, the exact same data structure. So what would I use instead of storage? The other keyword we could use is memory. If we use memory, it changes the way in which the variable behaves. If we use memory, an additional step will come into play. So if I executed this line of code that I'm going to show you, so if I did, got these diagrams, I need to use them, right? So this one here. So if I executed this line of code with the keyword of memory, it would take the numbers array and make a copy of it and place it into memory inside of our contract, and memory gets dumped anytime a function exits, and my array would no longer point at the array inside of storage. Instead, it's going to point to the new copy sitting in memory. So I'll look at the first element in memory, and when I click on numbers, it's, well, actually, we should try this, right? Let me go back to Remix so you could actually see this in action. We'll get rid of this, and come on. So I'll change this to memory. And so now I'm going to deploy for the second one. And so when I click on 0, I should get back 20. And sure enough, it's 20, which is what it originally was. In this case, when I modify an array or with memory, I was modifying a totally different array, not the same array. But why should we care about memory or storage keywords at all? So I'm going to add a new function to my contract, and I'm going to call this new function called change array. So what I'm going to do is I'll go ahead and get rid of all this, and then go ahead and add that new function, change array, like so. And this, I'm going to make this private. And so I'm making it private so that I cannot directly call change array. Only other functions inside the contract can do so. So I'm going to say that this array takes one argument of integers called myArray. And that's going to look like so. So integers, and it's going to be called myArray. Okay, and inside of the function, I'm going to take the first element inside the array and set it equal to 1. So I'm going to say myArray, first element, set that equal to 1. Okay, so at this point, I'm not calling change array in any way, shape, or form. I'm creating a new instance of this contract. So this function will not be invoked. Okay, I'm just curious to see what it says here. So function state mutability can be restricted to pure function. Anyway, I don't want to distract you guys. All right, so now I'm going to add a call to change array inside of my constructor. Okay, so in here, inside my constructor, I'll do change array and pass in numbers, like so. All right, so here's where things start to get interesting. Imagine in your head, what would happen if I deploy this contract now and try to access the first element inside of numbers? So I'm going to go ahead and deploy the contract once again. And there's the new deployment. Okay. And now I'm going to retrieve the first element. So here goes, 0. What do you guys think it is? Okay, it's got to be either 1 or 20. And what is it? And sure enough, it's 20. So what does that mean? So it means that we passed in the numbers array, received it inside the change array function, modified the array, but that modification did not change the numbers array. What that means is that whenever we pass a value into a function like I just did, we're actually making a copy of that array. So my array is a copy of numbers. So whenever you take in function arguments, they are assumed to be memory type variables. So it's assumed you want to make copies. It's assumed you want that behavior. All right, so however, or in any case, if we want to change the behavior, we could replace the memory keyword with storage instead, okay? All right, so the storage keyword in this case would mean do not attempt to make a copy of the array. Instead, take the numbers array and make that exact array available in the function. So the memory and storage keyword changes how we pass around references to these data structures. If you have never worked with a programming language that works with by value passing as opposed to by reference passing before, this may seem over the top. But even after all this is said and done, and I explained to you why I'm getting this array, the question still becomes, what is the solution in this case? Well, we know now that it's either going to be utilizing either the storage keyword or the memory keyword, one of those. So when working with Solidity, you're going to be creating contracts where you're going to be working with an array, mapping, or struct, and you may want to change the data structure and that's used from the original function that it's called from. And that's a great use case for storage. Otherwise, you don't need to use that keyword and just let Solidity work as usual. All right, guys, so in a subsequent video, I'll actually implement either memory or storage in this one. Which one it shall be, stay tuned for more.